Hello guys, so today I'll be discussing CodeChef Normal Challenge Division 2 second problem Chef and Ridges. Let's read the problem. We have a rectangular piece of cardboard with width 1. We are going to fold it in the following way. Pick up the right side of the piece of cardboard and move it to the left until it touches the left side. This way, a smaller piece of cardboard with width 1 by 2 half is created. If we unfold it, we could see a vertical ridge form in the middle. Picking up the left side of this new piece of cardboard and move it to the right until it touches the right side. Pick up the right side of the resulting piece of cardboard and move it to the left until it touches the left side. So, from these four statements, we are given a piece of cardboard. uh, I'll recommend you to use a piece of paper. I'll be drawing and showing you the problem, but I'll recommend you to take a piece of paper so that you can understand it better. So, as the first statement states, we'll pick up the right side of the piece of cardboard and move it to the left until it touches the left side. So, we'll pick up this right side and we will move it to this side, means we will be folding it, and when we'll fold it there will be a ridge form, and the size of paper will reduce off and there will be a ridge form in the middle. And then we will take the piece of cardboard form after folding, and then we'll move the left side to the right side, and again there will be a ridge form, and which will be here. And when we unfold it there will be total three ridges like this. And then when we will fold it again, we will be folding it from right to left. So from one time from right to left and other time from left to right. Let's see it ahead. When the cardboard is folded, exactly one of its new side is a newly formed ridge. So this line is important because this will tell us which ridge we will be selecting. That is, let's say what's written in bracket. There may be more internal ridges formed which we don't consider these. So the problem statement is that when we will fold it one time, there will be only one ridge. That is this one. When we will fold it for two times, after means after this, and when we will unfold it, we can see clearly there will be three ridges formed. So we will be taking this ridge because this is the ridge which is formed here when we fold this. If we hold this, if you hold the paper from the back side and open it, then this is the ridge which is formed we have when we have folded the paper the last time. That is the second time, and for third time we'll be looking at this. For the fourth time we'll again be looking at the last ridge which is formed and the time of folding. Let's read ahead. In total we fold the piece of cardboard n times, so we can fold it n times. After we unfold it and look at the formed ridges, let's designate the distance of ridge Rn, that is the last ridge from outer ridge from the left side of the original piece of cardboard by dn. For example, d1 is equal to 1 by 2. So the distance of d1, when we will fold it, there will be a only single ridge, and we will be taking this distance from left hand side. So this distance will be half, and when we fold it for the second time, there will be three ridges, but we will be selecting only this ridge as this is the ridge formed due to this. This is the ridge which is formed when we fold for the second time. So the distance of this is 1 by 4. It is possible to express dn as an irreducible fraction x by y. Find this fraction. So we need to find the distance and we need to find this irreducible fraction divided by y. Assume that if it is possible to fold the piece of cardboard as many times as we want, so we can fold it for number of time, but in the question it was given the constraint was 25. So let's now look at the input. There will be uh, P number of test cases, denoting the number of test cases, and N, which will the number of times we'll be folding a piece of cardboard, and we'll be printing the value of X and Y for each N we have provided. So for one, the output is 1 by 2, means the value of X or 1 is 1 and the value of Y for 1 is 2, and for 2 the value of uh, distance of ridge is 1 by 4. So the value of X is 1 we will be representing, and the value of Y is 4. Now let's look at the explanation. As we have already discussed the explanation when we fold it. Now we'll be looking at the pseudocode for the value of n is equal to 1 to n is equal to 5. So for n is equal to 1, as already discussed, it will be 1 by 2, and for n is equal to 2 it will be 1 by 4, and for 3 it will be 3 by 8, for 4 it will be 5 by 16, and for 5 it is 11 by 32. So now if you look carefully, there is a pattern which is being followed in the denominator, that the value of denominator is always increasing by 2. So the value of denominator can be obtained as 2 to the power n, and if we want to obtain the value of numerator, then for every value we'll be looking at the even number that has occurred before that n. So if n is equal to 3, the even number that has occurred before it is 2. So we'll take this value of 2, that is 1 by 4, and we will add it with 1 upon 2 to the power n, and where n is 3 and the value of 2 to the power 3 is 8. So 1 by 4 plus 1 by 8. Then LCM will be 8, and 2 plus 1, which is 3 by 8. So as you can see that this is the value which we have obtained, and this is the correct value, and now we'll be looking for n is equal to 4. So the even number that has occurred before this is 2. So we'll again take the value of 2, that is 1 by 4, and we'll be adding it with 2 to the power n. Here the value of n is 4, and 2 to power 4 is 16. Now again taking the LCM, 16, and 4 plus 1 is equals to 5 by 16. Now for 5 we'll be taking the value, the even number of n that has occurred before it. So the even number is 4, we'll be taking its value, that is 5 by 16, and we'll be adding it with 1 upon to the power n. Here n is 5 and 2 to the power 5 is 32, and LCM is 32, and this will be 10 plus 1, which is 11 by 32. And for n is equal to 6, we will again take the even number that has occurred before it, and um, before 6 the given number is 4, so we will be taking 5 by 16 plus 1 upon 2 to the power n, and here the value of n is 6, so it is 64, and LCM is 64. This is 20 plus 1, it will be 21 by 64. And for n is equal to 7, we'll be taking the value of n is equal to 6, that is 21 by 64. 21 upon 64 plus 1 upon 2 to the power n, that is 128, and the LCM will be 128. This will be 42 plus 1, 43 upon 128, and we will find all the rest of values using this. And we need not to apply any formula for calculating this. You can apply, but as the constraint given in question was 1 and lies between 1 and 25, you can either use a formula, or you can just simply use 25 if else condition, like I have used in my solution. That will be in the description link of the solution, that is in Java. You can see it from the link given in the description. So this is how this question was to be done. So if you like the video, don't forget to hit the like button. Do subscribe if you want more such videos. I'll be posting much more. And don't forget to hit the bell icon, and don't forget to share this video.